Hi and welcome to this session. My name is Atul and I'm a Cloud Application Architect at the AWS Professional Services team. In this session, we are going to talk about the AWS Microservices Extractor for .NET. Quickly walk you through the agenda. We are going to discuss modernization on AWS with focus on modernizing older monolith application to microservices architecture. We will go through the overall modernization journey and various pathways on AWS. We will look at various challenges of monoliths and how we can benefit from moving to a microservices-based cloud-native architecture. We will look at how Microservices Extractor for .NET can help you accelerate the modernization of monolith applications. We will then go through the prerequisites of the tool and walk you through a demonstration of the tool in action. We will then wrap up the session with key takeaways and additional resources. Let's understand what do we mean by modernization. Modernization is a process that the organizations follow to progressively transform an existing legacy application and infrastructure to a cloud-native state. This allows to reduce tech debt and enable new business capabilities with a shorter time to market. I would like to stress upon the fact that modernization is an iterative process and most of our customers prefer to keep it progressive, addressing one domain or business capability at a given point in time. The key question is why modernize Microsoft workload? One of the key drivers is to optimize application architecture. As an organization, when you have needs to go cross-platform or targeting microservices architecture using Docker containers or building highly scalable and performant systems, the ideal upgrade would be to port to the latest .NET version for your server applications. Decomposing monoliths to microservices brings freedom to adapt and experiment quickly. AWS has the broadest set of container and serverless technologies such as Amazon ECS, Amazon EKS, AWS Fargate, and AWS Lambda. These services have deeply integrated .NET support to power your modern architectures. Next one is reduce hosting cost. When you move to open source, you no longer pay for expensive Windows or SQL Server licensing. On top of this, moving to DevOps with containers and serverless allows you to reduce TCO and maximize compute consumption. Next up is operational efficiency, which brings in further benefits by eliminating server management and higher ops automation. With investment to innovation, we understand that the organizations would rather like to focus more on building products and capabilities that offer maximum benefits to their customers and spend less time managing the underlying infrastructure to run and operate on. As you can see in this representation, once we start iteratively transforming applications from legacy state to the cloud-native optimized state, our velocity to innovate increases while the cost continues to reduce. The key contributors to this includes monolith to microservices transformation, coupled with seamless and fully managed cloud deployment approach using containers and automated DevOps model. Let's look at various modernization pathways for Windows application. The first one is relocate or rehost. This largely involves moving Windows workload running on-premise to VMs in cloud. So for instance, if you have a .NET Framework application running on-premise, you would move it as is to cloud and run it on Windows EC2 instances. This acts as migration of workload with no changes at the code level. The next up is replatform, where the applications which are running on VMs are containerized to develop and deploy faster to cloud and run it on AWS managed services such as Amazon ECS, AWS Fargate, and Amazon EKS. The last one is refactor or rewrite, and as the name suggests, it requires application level code changes such as refactoring .NET Framework applications to .NET 6, or breaking down the monolith to microservices and run on AWS managed services such as AWS Lambda. This approach yields maximum benefit in terms of license freedom, savings, and performance improvement. This is the approach that we are going to be focusing on for the rest of this session. Let's go through some of the key challenges that the organizations are facing today. The challenges include increasing the innovation velocity to accelerate the rollout for key domain-specific business capabilities. The ever-increasing technical debt due to monolith architecture affects the ability to meet business agility needs. And as the business grows, it becomes extremely challenging to meet the scaling, performance, reliability, and dynamic scaling aspects during the traffic surges on the platform. Let's talk a bit about the monolith applications. Monoliths will typically have all business logic in the same code base and deploy it generally as a single host. In terms of challenges, monolith reduces the flexibility that should be part of the agile development process. For instance, all services and components of monolith architecture use the same memory, which makes it less flexible in terms of scaling. With the legacy approach to IT infrastructure and the overall app deployment, the whole app had to be addressed as a monolithic entity. And if the demands spike, the whole application had to be multiplied to accommodate the load, which meant multiplying the servers or virtual instances on which the application is running. This becomes a constraint to the dynamic and targeted scaling for a specific domain service or capability. As I mentioned earlier, monolith applications tend to have huge code bases. Making a small change in a single function can require compiling and testing the entire platform, which goes against the agile approach that the teams generally favor. Another key problem with monolith application is the reliability. Monolith applications have high module interdependency as they are tightly coupled in nature. The different modules utilize functionalities in such a tightly coupled manner that even a single module failure brings down the system due to the cascading effect. Quite similar to the dominoes failing. We all know that a user not getting results for a product search would be far less severe than the entire system coming down on its knees. Let's look at some of the benefits of microservices architecture. Microservices are independently manageable services, which allows us to enable more and more services as the need arises. And this minimizes the impact on the existing services that way. It is possible to create or upgrade each service individually rather than upgrading the entire application at once. The pluggability nature of a microservice application architecture allows for easier and faster application development as well as the upgrades. Developers can quickly build and deploy a microservice, then plug it into the architecture with less risk of coding conflicts and the outages. More importantly, due to the independence of each microservice, teams don't have to worry about the coding conflicts, and they don't have to wait for slower moving projects or teams before launching their part of the application. With a microservices architecture, the failure of one service is less likely to negatively impact other parts of the application because each microservice runs fully in an autonomous way. Large distributed microservice architectures tend to have many dependencies, so developers need to also protect the application from a dependency failure related shutdowns if at all. The capacity of each microservice to run autonomously makes it relatively easy to build, upgrade, delete, and test in isolation. This can be done without disrupting the other microservices that comprise of the entire application. And when the demand increases, you only need to upgrade or divert more resources to the microservice affected by the increasing demands. When rightly configured, a container orchestration tool itself can scale individual microservices in an automated fashion by allocating more resource and power. By only scaling the resources that it needs for as long as they need it, enterprises can save on the cost of the cloud server resources. Some of the common challenges we hear from our customers is that while the engineering teams understand the overall patterns of architecture that is required to modernize, but they struggle to apply the same to the product architecture in a holistic fashion. The teams are unable to carve out and identify parts of the application which needs to be extracted out as a service and map to the identified business domain and related processes. The other challenge we have heard from our customer is that it takes up multiple tool executions to correlate the application source code with the runtime profiling metrics data and then eventually visualize the dependency graph. Furthermore, the team spend significant amount of manual effort extracting out the dependent classes and components and deploying those in a standalone host. With that, let me introduce you to the AWS Microservice Extractor for .NET. AWS Microservice Extractor for .NET is an assistive modernization tool that helps to reduce the time and effort required to break down large monolith applications running on the AWS cloud or on-premise into smaller independent services. These services can be operated and managed in a fully independent fashion. Microservices Extractor analyzes the code of your target application and creates a visualization of the source code for you to visualize and see the components that you would like to extract. The visualization would include classes, namespaces, and the other method calls that happen between them. The visualization of your application helps you to logically group functionalities based on criteria such as class dependencies, namespaces, and the overall call counts. When you isolate the functionality of the application into groups, Microservice Extractor provides assistive guidance to refactor your code base to prepare it for extraction into smaller services using those groups. When the code base is ready for extraction, Microservice Extractor extracts the functionality into separate code solutions. You can then manually edit and deploy these solutions as independent services. Now let's see how overall the tool actually works. The first step is scanning the application. The extractor tool onboards the application upon accessing the application source code and the binaries. The backend server logic of the application is analyzed by the Microservices Extractor to understand the application and the node structure, and of course the dependency between these nodes. The result of this analysis will help you understand how to better group functionalities into separate services. If you have access to runtime profiling data that represents production usage, you can optionally use it with the analysis to collect actionable runtime metrics. If the Porting Assistant for .NET, which is another tool from AWS, is installed on your machine, you can optionally include .NET Core compatibility data in the visualization side panel. Once the assessment is complete, the next step is grouping the components. Microservice Extractor creates a graphical representation of application that shows the nodes, dependencies, and groupings based on the dependency coupling. If you have uploaded the runtime profiling data, as I mentioned, during the application onboarding, then that will also be displayed. This graphical representation assists you with the overall extraction of the group of nodes that you would like to isolate as a service. Now that you're ready to begin extraction, after the parts of the application that you want to extract are grouped and selected, you're ready to kind of move to the next step where you will extract this as a group, as a separate code solution. Once you have extracted the group as separate solution, you can manually edit and build the code solutions and deploy them as independent services in containers, for instance. Now, the AWS Microservice Extractor for .NET creates multiple visualization of the monolith application nodes. It provides data on the application structure required to help you decide what parts of the application you want to extract as smaller independent services. You can use the visualization to isolate dependencies and automatically capture interdependencies to create groups of closely related nodes. Nodes within each group rely on other nodes within the same group. In visualization, you can also view the method call count numbers between the nodes. And again, like as I mentioned earlier, the call count data is provided by the runtime metrics that you upload in the tool during the onboarding process. The tool also provides a high-level understanding of your monolith application and investigate dependencies and call count metrics to make decision about the part of the application to extract and create independent services. Now there are two visualizations that you see on my screen. On the left side you have the graph visualization, and on the right you're viewing the associated runtime call count. First up, the graph visualization in the tool. The AWS Microservice Extractor for .NET analyzes the source code of a monolith application and creates this visualization of the application code. This includes nodes, dependencies, call flows, as well as the relevant metrics. You can use this visualization, as I said, to make informed decision about the structure of the application and then identify the part of the application that you want to group and extract. On your right, as I said, you see the associated runtime call counts. The AWS Microservice Extractor for .NET includes an application runtime profiler to provide call count data with dependency details in the visualization of application. The output of this profiler is processed by the assessment tool to create this particular graph. This visualization representation helps you to focus resources during the extraction process and to isolate areas which are of high value to you. The runtime profiler, as I mentioned, is a simple DLL file that must be included when you run your application in a lower environment such as test or integration, with the data which is representative of the data that you would typically have in the production. Now, I just want to summarize on the key features of the AWS Microservice Extractor for .NET. So the key features is about assisting in refactoring source code and extracting out the identified group classes as independent services. The tool extracts and creates new code projects for the identified components in the working directory that you have specified in the tool, and at the same time refactors the calling code to replace the calls that are there in the code with the REST calls to the extracted services. Here are a set of prerequisites which you will need on your machine in order to successfully run AWS Microservices Extractor for .NET. You must have a valid AWS CLI profile to publish metrics. In order to set this up, you can follow instructions in the additional resources section. The application source must be a .NET Framework application or a .NET Core ASP.NET Web application with appropriate .NET Framework pack installed. The application source code must be in a building state using the MS-Build utility. Please also go through the rest of prerequisites as you see on the slide around the application analysis as well as the extraction. With that, we will switch to the demo of the AWS Microservices Extractor for .NET. Alright, so let's get started with the demonstration. Before I kind of get into the demonstration of the tool, let me share you the link where you can download this tool from. This tool is freely available on aws.amazon.com. Once you download this tool on a Windows machine and installed, this is how the landing page of the tool would look like. Now, before you can start using this tool to perform extraction and analysis of your application, you will have to perform some configurations. So let's click on the settings. Now, as you can see on my screen, I already have this tool configured. So you see all the configurations already being populated and you see an edit button. But if you're using this tool for the first time, you will have an add button to allow you to perform these configurations. So I'll go ahead and hit edit. The first option that you see is the selection of the AWS region. This is what the tool uses in order to communicate with the AWS. The next one is the AWS profile. Now this is the AWS profile, which allows the microservices extractor for .NET to assess your application. Now in my case, I already have a default AWS profile configured, which is connecting to my AWS account. In case if you wish to create your own name profile, you can always hit this option and click on add a name profile. This will allow you to enter a new profile name, access key ID, and a secret access key. In case if you do not have access to the access key ID and the secret access key, you can head to your AWS account on AWS console, create an IAM user, and access the programmatic access keys and configure it. The next one is the working directory. This is the directory in which the tool will store the output from the analysis and extraction of your application. Now there are certain limitations in terms of the length of this working directory path. So it should not be longer than 150 characters. And this limitation is primarily because of the MSBuild utility that the tool uses in order to build your application. The next option is AWS Microservices Extractor for .NET Usage Data Sharing. When you share your usage data, the AWS Microservices Extractor for .NET will collect this information, and it will only collect the public NuGet packages that you're using, the APIs and the stack traces. But in case if you wish to not share this data with the team, you can always uncheck this box. In my case, I will leave it to the default. Now the configuration for the Microservices Extractor for .NET is complete, so I'm going to hit the update button. Alright, so now I'm back to the landing page, and as you can see here, there are currently no applications onboarded onto this tool. And it also kind of gives you a view of all the 4 stages that are part of the AWS Microservices Extractor for .NET. Now, to summarize it back, you start with the onboarding the application onto the tool. You then move on to visualize the application, to see the various classes and their interdependencies. The third step is, once you have identified the service that you would like to extract out of this monolith, you will perform the refactor and extract step, which once done will create a new extraction group for you, and the output of the tool will be placed inside the working directory. Once that extraction group is available to you, you can perform additional manual refactoring post this extraction, and you can deploy this service in isolation. Alright, so let's get started with the first step of onboarding the application. Now, for purposes of this demonstration, I'm going to be using a sample application called Gadget Online to perform the step number 1, 2, 3, and 4. Now, this is how the sample application looks like. So it is basically an online gadget selling application. So you see the listing of all the gadgets, and you have various navigation options on the left. Now let me quickly walk you through the application source code. So this is how the application source code looks like. So it has various controllers. As you can see, you have the checkout controller, the home controller, shopping cart controller, and the store controller. All of these controller interacts with the underlying services such as inventory, order processing, and the shopping cart. Now, to take an example, if I go to the home controller, it has an action called index, which in turn calls the inventory services get bestsellers method. And this method then further interacts with the store service to connect to the database and pull the listing of all the products based on the count. So what we want to do now is we want to basically scan this application using Microservices Extractor, visualize the various classes of this application, and identify and see the dependencies between each other. And then take a decision on identifying an extraction group that we would like to host as a separate microservice. Now let's see if the Microservices Extractor can help us do that. So I'm going to switch back to the tool, and I'm going to hit on to do the first step, which is onboard the application. So I'm going to hit on onboard. So we will give a name to this application. So I'm going to just refer to as Gadget Online, and performing the abstraction for the Gadget Online application. So I'm just giving a brief description of what we're trying to do here. Once I do that, the next thing that I need to do is to select the source code, and what we select here is the solution file of the application. So I'm going to go and select the Gadgets Online solution file. Next up is the MS build path. Now, as you can see, the tool automatically pre-populates all the available MS build versions on your machine, and you can see that it found 2 different versions. Since on my machine I'm running Visual Studio 2022 and Visual Studio 2019 in parallel, so it finds both of those on my machine. So it automatically picks up the latest version, so I'm going to let it be like that. Now the tool also gives you option to customize various build options. So you can pass various arguments that it is using. You can actually remove some of these, or you can add, but I'm going to just stick to the defaults here. The tool also lets you select or pass the runtime profiling data. Now the runtime profiling data includes runtime usage metrics, which can be overlaid on the visualization graph in the next steps. Again, this is optional, and it basically, as I explained earlier in the presentation, this tool comes with an additional library which you can use to collect this data. For this demonstration, I'm going to select an already existing file that I have with me, which has the profiling data. So let's move on to the next step. The next step, it is asking me if you would like to analyze the application for .NET Core portability. So for instance, this particular application that I'm currently using for the demonstration, it is written on .NET Framework. So I can basically also check the compatibility of this application for it to be moved to .NET 6, for instance. Now, this is possible only if I have Porting Assistant for .NET running on the machine that I'm running this tool from. In my case, I have Porting Assistant installed, so I'm going to select this option. To give you a brief view of what Porting Assistant is, so porting application for .NET is, if you're performing this step, it is a significant manual effort. Porting Assistant for .NET is an analysis tool that scans .NET Framework application and generates a .NET Core compatibility assessment for you, helping you port your applications to Linux faster. Porting Assistant for .NET quickly scans .NET Framework application. It identifies incompatibilities with .NET Core, finds known replacement, and generates a detailed compatibility assessment. This kind of reduces the overall manual effort involved in modernizing your application to Linux. It also provides you an option to do assisted porting while using this utility. So now that I've selected this option, I'm going to hit onboard application. So as you can see on top of my screen, the Gadget Online application is successfully onboarded, and the AWS Microservices Extractor for .NET is currently analyzing the application. So with that, we have completed the step number 1, and the Microservices Extractor for .NET is currently performing the action number 2. And as you can see here, the application that we just onboarded is listed under the application. It also shows the type of your application, which is .NET. It shows the location at which the source code is located and the current onboarding status. Like I said, it is the Microservices Extractor for .NET is currently performing step number 2. So the visualizations are not yet available. So once the onboarding status is complete, the visualizations will be available for you. Now, this entire process of analysis takes a couple of minutes. So I'm going to put a pause, and I'm going to resume again once the visualization is ready for us to view. Alright, so the step number 2 is complete. The application is fully analyzed, and as you can see in the status here, the onboarding status is success. So I'm going to select our Gadget Online application, and I'll just walk you through some of the options that are available in the tool. So in terms of the action, you have the ability to edit the application details and rebuild and analyze the application again. You also have to remove the application and onboard a different application if you wish to. And you can maintain multiple applications at a given point in time using Microservices Extractor for .NET. All right, so let's start with the visualization. So I'm going to hit launch visualization for the application that we have just assessed, which is our Gadget Online application. And this is the visualization that you would see when you do that. So I'm going to zoom in a little so that the classes are clearly visible. So each node that you see here on this visualization represents a class. So for instance, if I'm looking at the inventory class, this is the node which represents that inventory node. Now let's look at the inventory node details. On your left side, it indicates you the details for the selected node. And what you see here is the list of nodes, the edges, the dependencies, and the call counts. The edges represents the dependencies between two nodes. Now this could be an incoming dependency, which is indicated in blue, or this could be an outgoing dependency, which is indicated in red. So for instance, the inventory service has an outgoing dependency on category model, and it invokes the category model with all the instrumentation that we have data that we have collected. It has invoked it 400 times. This data is coming from the profiling data that we have separately added to the tool while onboarding it. Here, as you can see, the inventory module is dependent on the product model, and it called the product model on about 184 times. In the same way, you will also see the incoming dependencies. So for instance, home controller is invoking inventory service, and it has invoked that particular inventory service one time. The second tab that you see here is the .NET Core portability, which indicates how portable your code is to .NET Core so that you can run it on Linux. This data is currently coming from the porting assistant for .NET, which, if you remember, while onboarding the application, I enabled as one of the options. Again, this is an optional data. If you have porting assistant, if you need to see the code compatibility for .NET Core, you can enable this option. And once enabled, you will see that at the node level. You also have some couple of alternate visualizations, such as namespace view and island view. To give you a brief, the namespace view kind of groups all your nodes or the classes as per the namespace. So you can see that the Gadget Online and all the controllers are kind of grouped together in the Gadget Online.controller, and in the same way, all the view models are grouped in the Gadget Online.view model. All right. So let me switch back to the main view now to show you how the other aspects work. Now, if you're analyzing a large monolith application, this can be super complex to view. So you have, like I said, either you can select a particular node and zoom on it, or you can also use the filter. So you can do a node name and you can select a particular node, and this will highlight all the dependencies, both incoming and outgoing, for that particular node. You also have the ability to filter using the group names. However, since we have not created any group yet, it doesn't show you any options. So let's go ahead and create a node group. So I'm going to just zoom in it a little so that everything is viewable clearly. And I'm going to select the inventory node. And let's create an extraction group for inventory service so that we can run inventory service as a separate microservice. So I will select the inventory node. I will right click on that node for me to be able to extract this. So let's go ahead and select inventory node and right click, and I will say add node to the group. Once I do that, it gives me an option to use an existing group or create a new one. Now, as you know, I do not have a group created yet. So I'm going to hit new and I'm going to name it as inventory service. The next option is it allows me to choose a color coding so that the group is clearly visible when I'm looking at the overall visualization. So I'm going to do that. I'm going to select green and I'm going to hit add. All right, so as you can see, the extraction is complete for the inventory service, and we have an inventory service group that got created. You also have the option to add other nodes, so you can simply drag and drop a node into this group and you should be able to add an additional class into that same extraction group. let's look at some of the details of what an extraction group contains. So you have, in this particular case, we created an inventory service extraction group, and this extraction group has certain dependencies that got added when we started to create this extraction group. So you will see all those dependencies under the general tab. So you see the various dependencies that it extracted as part of the inventory service. So you have the configurations, you have the models like categories and cart. You also have other online entities, etc., that got extracted. So in total, there are 37 dependencies which are part of the inventory service that got extracted as part of this extraction group. Once you've created the extraction group, you have the options, like I said, to view the group details, which you're already viewing. You have the option to modify the group name. You can remove all nodes and completely delete the group and create a new one. And you also have an option to extract the group as a service. So this option allows you to create an extraction group and extract this as a microservice. So I'm going to create this extraction group and I'm going to name this as inventory service. I will leave the description as optional. And as you can see, all the dependencies which are part of this extraction group are listed down here again for you. It also indicates the .NET Core portability for each of these classes. So all 37 dependencies which are going to be part of this particular extraction group are all indicated here with their .NET Core portability. And here in the top, it also indicates that these are all part of the green labeled inventory service module. All right. So now with that, I'm going to go ahead and go to the next option, which is how do you want the existing monolith to invoke this extracted microservice? So now here we have two options. We have the option to use remote method invocations, which means that the existing monolith, which is the Gadget Online application, will be invoking this extracted inventory microservice over HTTP. So that will be an external call that will happen, and the microservices extractor can make changes in the existing application source code to invoke this microservice over HTTP. You also have the option to use local method invocation. So you can switch to this, which would allow you to invoke it just like, though it will create a separate extraction, but it will still invoke that extracted module by directly referencing that particular library. So you have both the options available. For the purposes of this demo, I'm going to stick to the first option, which is to use remote method invocation. With that, I'm going to hit extract. And now, as you can see on my screen, the extraction has started. This process is going to take a couple of minutes. So I'm going to pause the video and I will resume once this is complete. All right. So as you can see on my screen, the extraction of the inventory service was successful. And here are some of the output locations that the tool is clearly calling out. So you have two key output artifacts. One is the extracted service. So the extraction, the group that we created, it all got extracted out into a separate microservice, into a separate solution. The second one is modified application code. So now, since we chose the option of remote invocation from the existing monolith, the application source code, the as-is application source code also got modified in order to invoke this extracted microservice over the rest. So we're going to go through the source code for both of these output artifacts. So I'm going to just select the extracted service and let's navigate to that folder. And so this is where the extraction got created inside my working directory. So I have two key artifacts. Like I said, I have the extracted service as well as the modified application code. So we're going to first look at the extracted service, which I already have opened on my machine. So we're going to quickly view that. So as you can see, this is the extracted solution for Gadgets Online, and it has all the dependencies that were part of the extraction group. So whether it is the model, so you can see all the entity framework model classes, you have the cart, the category, all the classes on which the inventory service was dependent on. If I go to the inventory service, the class implementation of inventory service is now refactored and created into an API action. So you can see that the get bestsellers is now available as an API action, and the inventory service has now become an inventory controller. One thing I would like to call out, while in this particular case we extracted out the inventory service, the extraction is not always going to be clean. So there can be cases where you may have some compilation issues. So the extraction will always not compile 100%. So you may have to look at some of the build errors that you might encounter post the extraction of the microservice. So for instance, in my case, the microservice extractor chose to pick up the DB migration files as well, which are clearly not applicable for this extraction. So now that we have seen the API inventory microservice that got extracted out of the source code, let's look at how this is going to be invoked from our existing code. Now, before I show you the updated code for the Gadget Online monolith application, let's first look at the code as is. So even before we started extracting, how was the code earlier? So for instance, on the home controller, the way inventory service was invoked was we just basically created an instance of inventory service, and we invoked the get bestseller method on the inventory class. And this class was located right here in the source code, and this class was directly invoked, and this was an in-process call directly to the inventory service. Now, once we ran the microservices extractor and we extracted out the inventory microservice, this code has to be changed to invoke the inventory component over REST. So now let's look at the code that the microservices extractor generated for us by modifying the existing Gadget Online code. So for instance, if I go into the home controller, this is the updated source code for home controller looks like. So as you can see, it is creating an instance of inventory endpoint factory, and it is returning us, by calling the get endpoint adapter, it is returning us the inventory capability, and then we are calling the bestsellers method on top. The inventory endpoint factory is basically an adapter, that the factory implementation that the code has created for us, which allows us to kind of manage the connections to our the inventory service. So we have the option to either load it by calling the remote endpoint, or if we wish to test it by directly calling the inventory service, it allows us to do that. And this is being currently managed through this configuration, which is use remote endpoint. So base is the one that you choose, and this configuration can be controlled through the web configuration file in the application. So here, if I go into the web config, you would see that you have a flag of remote routing to microservice. So you can change the value of this flag, and basis the value of this flag, if the flag value is set to true, which is route the call to the microservice, in that case, the inventory endpoint factory will route the call to the remote endpoint of inventory microservice. But if this flag you set to false, it will do an in-process call to the inventory service, which still exists in the implementation as it was earlier. So you can still continue to invoke it like that. One additional point that I want to call out while going through this extracted code and the way that extracted code is being invoked is that depending on the way you are invoking your application source code, the way microservices extractor or the output that a microservices extractor would generate may vary, and you may have additional compilation errors that you may need to fix. Or there could be a scenario where the microservice extractor is unable to change the code in your calling monolith, due to the way it's been implemented. So you may have to do additional refactoring in order to invoke your target microservice. So with that, I wrap up the demo of the microservices extractor for .NET. As part of this demonstration, what we saw is the 4-step process of how the microservices extractor works, which starts with first onboarding the application, and then once the application is onboarded, you move on to the launching of the visualization, where you actually see various, you see the complete dependency graph of how your application is structured, and you have the ability to select the right nodes and create a node group for the extraction. Once you do that, you move on to the 3rd step, where you kind of select that node group that you have created and you extract that out as a separate microservice. The 4th step is obviously you will address any further compilation errors, and then you're ready to actually build that application, the extracted microservice, and deploy it in isolation and then integrate it with your existing monolith. With that, I'm going to switch back to the presentation slides. Alright, let me quickly summarize what we discussed today. The AWS Microservice Extractor for .NET simplifies the process of refactoring your application into independent services. It lets you seamlessly modernize and transform your applications with an assistive tool that analyzes your source code and the provided runtime metrics to create a visual representation of your application and its dependencies. Microservice Extractor for .NET delivers holistic application visualization and assists you in the code refactoring. You can also use this tool to extract the code for the microservice into a separate project that teams can develop, build, and operate independently. Here's a quick set of additional resources which you might find useful for setting up and using AWS Microservices Extractor for .NET. With that, it brings me to the end of this session. Thank you for listening in, and I hope you found this session useful. Thanks again.